Okay, so think about your absolute favorite programming language for just a second. Maybe it's C++, Python, Java. Now, what actually makes them work? Right, it's that strict logical structure, the syntax, the rules. If you miss a single semicolon or use the wrong operator, boom, your entire code breaks. Well, what if I told you that human language, specifically technical English, works literally the exact same way? In today's tutorial, we're not going to look at English as some messy, random collection of words. Nope. We're looking at it as a highly structured, totally logical system. We're talking about grammar as code.
I'm your instructor, Mrs. Swain, and I want to give a huge, warm welcome to all my second-year computer science students from the L2 ACAD, ISIL, and SIGIL programs right here at USTB. Now, I know that as future computer scientists and software engineers, your minds are totally wired for logic, right? You build algorithms, you design complex systems. So my ultimate goal for this explainer is to translate English grammar into a language you already speak natively, logic. By the end of this session, you're going to view writing an English sentence exactly the same way you view writing a block of code.
Here's our quick syllabus for today's tutorial. First, linking words. Second, practical examples with AI. Third, sentence types. And finally, join the class. Let's just dive right in. Section 1. Linking words, or as I like to call them, conjunctions as logic gates. So in English, linking words, or conjunctions, are essentially your operators. Think about it. If you want to connect two pieces of data, or maybe two functions in programming, you absolutely need an operator, like and, or not. Conjunctions are exactly that. They're literally the logic gates of the English language. And we can map these out into three main categories. First up, coordinating conjunctions, which act as simple bridges between two completely equal ideas. Second, correlative conjunctions. These actually work in pairs. You can kind of think of them like opening and closing brackets around your logic. And third, subordinating conjunctions. These establish a strict hierarchy, basically making one idea completely dependent on another. So whether you're trying to express a cause, addition, contrast, or a choice, there's a very specific syntax tool for the job. Now, let's zoom in on the most fundamental logic gates, the coordinating conjunctions. I really want you to memorize this acronym, FANBOYS. That stands for, and, nor, but, or, yet, so. These are your foundational keywords. Just like you literally have to know your basic operators before you can even think about writing a complex algorithm, you absolutely need to know your fanboys to write clear technical English. They sit right there between two equal, independent clauses and dictate the exact logical relationship between them. Moving on to Section 2, Practical Examples with AI. Let's see this grammar in action. Okay, so theory is great and all, but let's actually see how this compiles. To discuss cutting-edge concepts like artificial intelligence effectively, you really need robust grammatical structures to convey nuanced technical ideas. Take a look at this sentence. Not only does AI perform repetitive tasks, but it also learns from data and improves continuously. Here, we're using a correlative conjunction not only, but also. Guys, this is essentially parallel processing in grammar. You're basically telling the reader, hey, execute task A and simultaneously execute task B. It brilliantly links two parallel capabilities of AI, giving them completely equal weight and emphasis in the sentence. It's just so much more powerful than simply saying AI performs tasks and AI learns, right? Now, this next one beautifully illustrates a strict binary choice. Either we shape AI according to our values, or we risk allowing AI to shape our values for us. The either-or pair, that is pure Boolean logic right there. It creates a mutually exclusive scenario. When you're writing about, say, ethics in technology or system limitations, using either-or actually forces the reader to confront a fork in the road. It is an incredibly effective tool for structuring a really persuasive argument without getting bogged down in messy, confusing phrasing. So the absolutely crucial point here is understanding dependency. Look at this sentence. If we regulate AI properly, it can become one of the most powerful tools ever developed. Here, we're using the subordinating conjunction if. Just like an if statement in coding, this establishes a super strict condition. The second part of the sentence, AI becoming a powerful tool, literally cannot execute unless the first condition, regulating it properly, is fully met. It creates a crystal clear cause and effect dependency. Section 3, Sentence Types, Building Complex Functions. All right, now that we have our logic gates, how do we actually build larger programs? Well, in grammar, this means constructing different types of sentences. I mean, you wouldn't write an entire software application using only basic print statements, right? Of course not. You use functions, loops, classes. Similarly, in technical English, you need to vary your sentence architecture to build a compelling and readable paragraph. Let's contrast our basic structures. On one side, we've got this simple sentence. AI is transforming the world. It has one subject, one verb. It's just one independent clause. Sure, it gets the job done, but it's very, very basic. Now look at the compound sentence. Machines are becoming more intelligent, so humans must develop new skills. We've taken two independent simple sentences and bridged them using our fanboys logic gate, so. Both ideas are completely independent, but the so establishes a direct consequence.
But what happens when ideas aren't exactly equal? Enter the complex sentence. A complex sentence contains one independent clause. Think of that as the main program, plus one or more dependent clauses, which are like your nested functions. These dependent clauses are attached using those subordinating signal words we just talked about. Because, although, if, when. Keep in mind, a dependent clause simply cannot stand alone. It absolutely needs the main sentence to run properly.
Here's a perfect example right from your course text. Although AI performs many tasks efficiently, it still lacks human creativity. That first phrase, although AI performs many tasks efficiently, is your dependent clause. If you just said that out loud and suddenly stopped, people would literally just stand there waiting for you to finish. It's incomplete logic. It relies completely on the independent clause. It still lacks human creativity to actually resolve the idea. Okay, really quick, let's talk about preventing compilation errors in your writing. These are crucial syntax reminders you definitely want to take away from this. First, if you start a sentence with a dependent clause, you must use a comma before the independent clause. Think of it like a bracket closing. Second, if you want to join two independent clauses without using a fanboys conjunction, you can actually use a semicolon. A semicolon is a surprisingly powerful tool in technical writing to show two really tightly related ideas. And finally, never ever leave a dependent clause by itself. That results in a sentence fragment, which is essentially a total syntax error. And our final section, Section 4, join the class and practice your code.
So we've covered the documentation, but now it's actually time to write some code. Understanding the theory of logic gates and sentence architecture, that's really only the first step. To truly master technical English, you've got to run the programs yourself. You have to practice. So I want you to ask yourself right now, how will you apply these logic gates to debug your own technical writing? The next time you're writing a lab report, a project proposal, or even documentation for your code, take a hard look at your sentences. Are they all just simple and choppy? Are you using the word and way too much? Challenge yourself to use a correlative pair, like not only but also, or to build a really solid complex sentence using although. I want you to debug your English the exact same way you debug your code.
To help you practice, here are your next steps. First, absolutely make sure you join our virtual classroom. Then I need you to complete the 3 exercises from Unit 7 and 8. In Exercise A, you're going to match sentence halves, which is great practice for your correlative pairs. In Exercise B, you'll combine simple sentences into compound ones. And finally, in Exercise C, you'll fill in the blanks with the correct conjunctions to totally fix the logic flow. Consider this your sandbox to test out all these new concepts. Look, your journey in computer science isn't just about communicating with machines. It's about communicating the brilliant things those machines do to the rest of the human world. Mastering these logical structures in English gives you the exact power to do that. Thank you so much for your focus today. I am Mrs. Sowen, and I cannot wait to see your brilliant, well-structured sentences in our USTHB class. Happy coding and happy writing.